All right, so now that we know a little bit more about game design, we're actually going to jump into monogame. So Unit 3 kind of introduces monogame. We bring back some old programming concepts that you should know and refresh your memory, but that's what we're going to focus on is we're going to look at what monogame looks like, look at the environment, and use it on a very basic level. So your goal by the end of class today is to be able to meet these two learning targets. First, your goal is to be able to explain the significance of using a programming language and why we have these programming languages. And then you'll simply be able to describe the basic template of monogame, and we'll actually have you go into monogame and look at the breakdown of the framework that we have, the built-in code, everything like that. So to start, we need to refresh our memory on some key vocabulary concepts. So this would be a good time to take some notes so that you know these key vocabulary words. When I use them in the future, you're good to go. So first, we need the word algorithm. And you hear this a lot in math. They'll say the mathematical algorithm or the algorithm for this, and they'll talk about an algorithm. And really all that is it is a series of steps or actions performed in order. So for example, when you're solving a system of equations and say you're using the substitution method, the first step is you decide which variable you're going to solve for alone. And then second, you solve for that variable by itself. Third, you substitute in for that variable. And fourth, you keep going on and on and on. And you have to do those steps in order. And there are specific actions that you have to do. And that's kind of what a computer program is we're writing an algorithm or a step-by-step process for something to occur. So when we're creating a game, we are actually writing an algorithm for how that game is going to run. And essentially what the algorithm specifies are the actions that are going to happen, and the order matters. So it's the order in which those actions are actually going to occur. So for example, some algorithms that you've seen in your everyday life. First, making a peanut butter and jelly sandwich. Think through, there are steps you go through. You wouldn't start to eat the sandwich before you put the peanut butter on it. You wouldn't smush the bread together until the jelly was on it. You want to make sure you put both sides of the bread with the peanut butter and the jelly on it together, things like that. Then you also have your rise and shine algorithm. And if you think about your daily life and how you function, you actually have an algorithm for when you wake up. So you get up, take off your pajamas, you take a shower. I mean, even just imagine if you flipped around the order of those two instructions or you skipped the instruction altogether, you'd be showering with your pajamas on, and that would be a little bit silly. So we have algorithms for everything, not just things in math or computer science. It's really how our whole world functions. We have algorithms, step-by-step process for how things occur. The second word that you'll need to know and that we will use heavily in this class is pseudocode. So a lot of times I will ask you to write down pseudocode for a process, and basically all pseudocode is a combination of English and computer programming language together. Basically, it's how you plan out your programming. So what you'll do is you'll show the steps and you'll write out the steps, but instead of saying it entirely in English or instead of saying it entirely in a computer science programming language, you'll kind of combine the two. So you'll say, if this occurs, do this. And you'll kind of break it down step by step using pseudocode. So you won't have to write out the exact code with every little letter and symbol correct to start off the bat. You'll just write out what we call false code or kind of pre-code, kind of getting a rough draft for what your code is actually going to look like. The second piece of this is, why do programming languages exist? A lot of the time students jump into like, why can't I just use English to describe what I want to do? And we use programming languages because they are very, very specific. If you think about our English language, sometimes the English language can be a little bit confusing and not specific. And sometimes students look at me funny, and so I start to use different words on them. So I have written in the PowerPoint, it says lead, which means to lead a bunch of people, and lead, the metal. They are spelt exactly the same, but depending on how you say them, they have a different meaning. So even though they look the same, they have different meanings. So imagine coming here from another country and reading that, you wouldn't know if they meant to lead or if they meant lead. And the same thing can happen, for example, if you have the word bass, like a guitar and having the bass in a band, and you have a bass, the fish. Bass is an instrument, bass is a fish. And again, they're spelled exactly the same, but they mean two different things. So that's why we can't really use English. And the same thing happens with phrases. You can use the phrase break a leg, and that can mean good luck. But if you read break a leg, it means somebody could actually break their physical leg. So English isn't a good language to use with computers because computers are very literal. Computers read it exactly as you've written it, and it will get confused on those types of sayings and those words that have multiple meanings, even though the spelling is exactly the same. So computer programming languages were in fact invented in order to have some straightforward language where each word, each instruction has one particular rule and it is very specific. And that way, when your computer reads your code, it reads it in order and it reads it and it knows exactly what each word means. So it's not confusing to the computer. Computers are not as smart as humans, whether or not you want to believe that. They are as intelligent as the person that programmed them, and they need very specific instructions. They cannot interpret anything. So something to keep in mind as you begin your own code is that computer languages are precise. There's no ambiguity. That you cannot misinterpret anything. Every single word has one meaning. So there are words that are off limits for variable names because they already have a meaning in code. And you have got to be very, very precise. The other thing is computer languages are perfect. Computers cannot figure out your misspelling. So be careful. You have to be perfect when you're coding. It needs to be spelled perfectly. And it needs to go in the exact order you want your computer to function. It will not know to jump around. It will simply go in order. So if something's happening too early in your game, maybe that's a sign that you need to go back and look at the order in which your code is actually running. So monogame, to give you a little bit of background, it used to be called Microsoft XNA, and it was a part of Visual Studio 2010, but after 2010, they no longer incorporated Microsoft XNA into Visual Studio, and that's where monogame came in, and it is a platform-independent software, so it can be used on Macintosh and Windows and Linux, and it uses the C# programming language, which we all know is growing in popularity in computer science. A couple of things about monogame is it actually has a pre-built skeleton framework that it kind of comes with automatically. That's what you code inside. It has some built-in methods and things like that, and we'll see that in a couple of minutes when we jump in. And then it also has some pre-built programming components, so it already has things built in for sounds and images and gamepads and keyboards and text and color and game loops and anything you could ever imagine. A lot of the things that are related to game design are already built in. So you'll be able to access the gamepad because it has some pre-built programming components in there. You'll be able to access different colors and create colors because it has those pre-built components. It has a game loop already built in, so it will continuously run 60 times a second. Things like that. It's already built for that, so we will just program inside of that environment. So if you're ready to jump in, I want you to move on to the next video. The next video will actually jump in and show you the basic breakdown of monogames. Now you have a little history behind why computer programming languages exist and where monogame comes from, and the next video will actually get you inside of monogame.